Good morning, everybody, and welcome to Math with Mr. W. Today's lesson is all about inequalities. Now, I'm not sure if this is going to be part of 7th grade. However, last year when one of my grandchildren was in the 7th grade, one of my granddaughters who's in the 7th grade last year, she had inequalities. So I'm only doing this because she was there, and perhaps some of you are dealing with the same thing. Now, first of all, if you've been doing equations, you're still doing equations. Your inequality should be in a straight line, just like your equal signs. You should be checking, just like you checked before. And there's only one thing to think about at the end. Only one thing different than what we've had with equations. Okay, so inequalities have not a whole lot of difference. So let's find out what that is. First of all, this is a standard inequality. It says that 3 times the number, subtract 11, is greater than or equal to 14. Now, we're going to do exactly the same thing we did with equations. We're going to have to move this 11 over the other side by adding 11 on both sides of the equation. Or in this case, 3x minus 11 plus 11 is greater than or equal to 14 plus 11. 14 plus 11. So, now, what are we going to have here? On this side, these are going to go out. And we're going to get 3 times some number is greater than or equal to 25. Now, we could make this easier. And since this is the first inequality we're doing, why don't we make this a little easier by simply changing this 3x to a 5x. Okay? We'll change this to a 5x. That's okay. Because we're just trying to learn something here, just learning a process. Okay, so now we get down to this point, just like you've done in an equation. Are we going to do anything different? We have 5x, and the 5 is positive, is greater than or equal to 25. Now, I have to either divide by 5 on both sides or multiply by its reciprocal 1/5. So let's multiply by its reciprocal 1/5. And on this side, we'll do the same thing. And it's going to be greater than or equal to. So the 5s will factor here. Factor, important thing. And x is greater than or equal to 5. Now, we check the same way we check when we do an equation. So we put the 5 back here into our original statement. So our original statement says 5 times. Now, this is our answer. So let's put a 5 here. Subtract 11 is greater than or equal to 14. Now let's see if that works. So we end up with 25, subtract 11 is greater than or equal to 14. Well, that's 14, and certainly it's not greater than, but it is equal to 14. And since that's an or statement, that's also important to understand. This statement is greater than or equal to. It's an or statement. This statement is greater than or equal. So that's 2 parts. Now, in Japan, they don't write it like this. They actually make an equal sign under here. And I think that's even far less confusing. But for some reason or other, Americans got a little bit lazy and decided that they were going to just have one of those bars instead of both bars like the equal sign. But this is greater than or equal to, and it's an or. So all I have to do is be one or the other, and we're fine. And we are good. So let's try another one. Now, in this case, we're going to have to do what to get rid of the 10? We're going to have to take it away because it's added. So we'll have 3x plus 10. We'll have to subtract 10 from both sides. 1 subtract 10. And in this case, we have 3x is greater than or equal to the opposite of 9. The opposite of 9. Now, what are we going to do to get rid of the 3? We have to, again, multiply by a third or divide by 3 on both sides. This time I'll choose to divide by 3 on both sides. Okay? And x is greater than or equal to the opposite of 3. Again, we have to know our rules for integers in multiplying, dividing, adding, subtracting. When you divide a negative by a positive, you get a negative. So our answer tells us that x is going to be greater than or equal to negative 3. So we have to put that value in here. So 3 times the opposite of 3 plus 10, the original inequality, is greater than or equal to 1. So we get the opposite of 9 plus 10. Is that greater than or equal to 1? So we get 1 is greater than or equal to 1. Well, 1 is equal to 1, so it works. So you have to just be able to know that, yes, this is true because it's one of those two parts. Now, let's see where things change. Now, think about this for a second. If I know that 2 is greater than 1, what happens if I multiply both sides by the opposite of 3? I multiply both sides by the opposite of 3. This becomes the opposite of 6. This becomes the opposite of 3. Now, if I were to keep my statement here greater than in this direction, I would be wrong because the opposite of 6 is not greater than the opposite of 3. So this changes. The order of, it's called the order of the inequality is flipped when I multiply or divide by a negative on both sides of my inequality. Only when I multiply or divide. Nothing to do with adding or subtracting. Clearly said that again. Nothing to do with adding or subtracting. When I multiply or divide by a negative, I have to change the order of the inequality. So let's see that happen over here. Now, in this problem right here, I have 5. The opposite of 3x is less than 2. And I have to get rid of the 5. So we're going to subtract 5 from both sides. So the 5 is gone here. So the opposite of 3x becomes less than the opposite of 3. The opposite of 3x is less than the opposite of 3. And here's where this guy becomes important. In order for me to get rid of this opposite of 3, I have to multiply by the opposite of 1/3. So over here, I have to do the same. The opposite of 1/3. So these two guys go out, giving me a positive x. These guys factor, giving me a positive 1. But what happens to my order of my inequality? It has to flip. Its order changes. So x now is greater than 1. Just like the thing happened over here, when I multiply both sides by an opposite, the order of the inequality must change. So, and I can go back and put this in here to see if that works. It says 5, the opposite of 3 times 1 is less than 2. So 5 minus 3 is less than 2. So we get 2 is less than 2. Now, is that true? Is 2 less than itself? No, it isn't. So this doesn't work, does it? So that's not true. So I've got to come up with a better way of answering this. My check didn't work. My check just didn't work. So is this answer here, x is greater than 1, a solution for my problem? Well, think about it. Here I put in 1, didn't I? That's not right, though. My answer said x is greater than 1. So I should have put in something here that was greater than 1. So I should have put something like a 2 in here. Okay, that would make that the 6. And now I have 5 minus 6, which is less than 1, negative 1. And negative 1 is less than 2. So what I didn't do is I treated this like an equality. I can't do that. It says x is greater than 1. So this item I put in here has to be something greater than 1 to check. Something greater than 1. It's not an equal sign. See, over here we had, remember these over here? They had an equal sign in there. So they could put that in there. But you can't do it when all it is strictly less than or greater than. So I had to decide, okay, what number can I put in here? Well, I have to find something that's greater than 1. So I choose 2. I could have chosen 1.5, 1 1/3, 1 1/4. Anything greater than 1. And when I check that, my answer works out. And so this is true. So you got to be careful. We had the right answer, but in our checking, we might look at that and go, did I do it right? 2 is not greater than self. We go back here and observe the fact that there's no equal sign there. So we have to be really, really careful. Really careful. Observe what it says. It says x is greater than 1. So I have to find a number to put into my check that's bigger than 1. And I chose 2 because it's easy to work with. I could have chosen 10 or 100, but 2 is easy. So when you're working with your students and you're doing these problems, make sure they read carefully, not only from the beginning, each statement, and know what they're doing, because otherwise they're going to make serious errors. They have to read carefully every part of the problem. See you next time. You guys have a great year and a great day. That's right. I'll see you next time on Math with Mr. W.